Come on. All right. Good morning, everyone. Welcome to week 5 of this module. First of all, I hope all of you are doing well. Just a reminder quickly, please. Couple of things before we get started for the module. Number one, I hope all of you have received my email for the data set. Okay. We will be talking about the coursework that's on the agenda today. That's what we are going to start with. So very, very important discussion. If you have any questions, it's a great opportunity to clarify that. Number two, from the way we are going, most likely we will have the main hackathon in week 8, first session. Okay. We will decide upon the date as it needs to be the common slot between both the batches. But we'll keep it for week 8, which is the last week of the module. We wanted it in week 7, but then I thought, this would give you slightly a bit more time to practice so that we could do the hackathon in week 8. So prepare yourself, make sure that you're not traveling anywhere because this has to be live hackathon. Preferably, most importantly, it has to be in class. Those who are doing online will have to keep their cameras switched on and the session will also be recorded just to make sure that the camera was switched on throughout the hackathon. Also, you will be given a different login ID and password, and we'll talk about that closer to the hackathon date. It will not be this account that you will be using. These links will be disabled, so you will not have a common access. You will have your own username and password in order to access the Data IT platform. Week 7, we will be having the mock hackathon, which will help you understand what the hackathon is all about. And then you have enough practice so that you can get into week 8. The deadline for the second coursework, which is the coursework that we are going to discuss today, is 30th of July, which means you almost are getting 1 month to work on the final project. And these are the two assessment components for your module. Are there any questions to begin with? I will be explaining formally the coursework now, the 60%, and then we'll get started with officially the first AI algorithm other than regression, which is logistic regression. We'll partially build a use case today. It will also help you understand how you can approach your coursework with the same sort of pattern. And we'll discuss logistic regression. We'll start implementing it today, and we'll continue logistic regression the next session. And this week we should finish logistic regression. Next week we should finish 2 other algorithms, which is decision tree as well as clustering, which is one of the unsupervised learning. So you will have 3 to 4 algorithms at your disposal to do the hackathon as well as the main coursework. Okay. Any questions anyone has to begin with? All good?
Sir, I have a
yes.
question.
Go ahead, please.
So we do have the Global Business Immersion trip, which I believe is July 25th to August 2nd.
Okay.
So would this be clashing with that by any chance?
No, so week 8 would be, so this is week 5 going on now, and then week 6, week 7, week 8. No, week 8 would be the week which is 20 to 24.
Okay, thank you so
Yeah.
much.
Yes. Okay. Are you sure about this? Yes. Yesterday, in the PVG or for that, okay. I can check.
So it would be, I don't think she had like the cookies and all.
Okay.
Once it would be for.
We can check. Yeah, once it is there, we can work around the thing. So that's not an issue. We'll figure it out. Okay, so first things first, let's talk about the main thing, which is the coursework. But before that, those who came late can quickly scan, and then I'll close the attendance. Done? Has everyone scanned? All right. Let's move on to the coursework. Come in. Okay, so to get started with the coursework, I want to start with a warning, first of all. Because there's a general tendency that the moment you get the coursework, you actually search online, is similar data available and, can I find some solution online and do something? Let me openly tell you, these are mostly available online, which means these are live competitions from Kaggle, from where the data has been shared with you. So don't jump off your seat saying that, oh, the data set I got telecom, the similar data set is available online. Definitely, it has been taken from a live competition. And why I'm telling you this is sometimes we do get this response. So, oh, this is available online and there is some Python notebook, something, and if you haven't attended any of the classes, you'll just take the code and submit. This is completely different for multiple reasons. Number one, the data, the values have been changed. Okay. Which means, there is a possibility that around 7, 8 of you would have received the same data type, which means the telecom data. But within the data set, the values might be different and it might be slightly different here and there. Maybe the IDs are different, maybe the revenue is different and so on. So first of all, the data values are different, number one. And number two, the idea of taking a live competition data is for you to work on something which is more realistic, right? And trust me, there is nothing online where you have a ready data IQ solution for your project. So it wouldn't say, this is what it is and just go and use it. So taking any solution from online is completely out of picture. But does that mean that you should not search what is online? Absolutely no. You should search online. You should read what people have commented. You should read what solutions they have taken. You should read, possibly what would be a good use case from that data. All that is completely allowed. Okay. But don't think that, oh, there is a ready-made solution available and, I can do it, because you cannot do it. The data is different. The ready-made solution is not for a particular use case. It could be for any use case which is not relevant to what you're doing. And there is no solution where, they could do something on data IP for you. You will have to build this from scratch. So it's not a 2 or 3 day activity where you did some GPT, you finish something and upload. There is a whole process involved in doing this, and hence this is 60% of your overall assessment. Now, the biggest challenge for your coursework, which you will face going ahead, are basically two challenges. Number one, to find a suitable use case. Now, nothing has been given, right? When I send the email to you, you have these general guidelines available, which tells you how to do the coursework, and you have the data set available, and you have the description of the data. But there is nothing that says you need to predict this, you need to do that, you need to do this. There are no objectives given for the coursework. And that's one difficult part of the journey. How do you set that objective for yourself? Okay. And I would say, ideally, to set the objectives, wait for this week also, because this week we'll be doing a categorical prediction. You'll be seeing how logistic regression works. You'll be seeing a standard example on how we go through. And then the way you look at your data might actually differ. So wait for this week's session also. In the meantime, what can you do this week is do research. What those columns are, understand the columns. Check if there is some additional data that you can source. Do some pivot tables, understand the relationship, do some BI. So set the background this week, and for the AI part, start thinking of it after this week on what the objective can be, what can you apply, and so on. Okay, so that's challenge number one. Challenge number two is the data has been designed in a quite tricky way. And let me explain what I mean by that. So the thing is, when you start applying models and when you start getting results, you actually might think that, oh, I'm getting amazing results. I'm getting 99% accuracy. This looks like a great model and so on. Even if I take two variables, it's giving me 99. And those are the things that we really want you to work on the project. It's not that, oh, you got 99, that means it's an amazing work that you have done. As an analyst, how do you critique that? How do you say, 99 sounds too realistic? Too optimistic. Is this something correct that I've done? Are some variables there which are highly correlating with the dependent variable? Hence, I'm getting that kind of accuracy. Even if I'm getting 99% accuracy, does it look really accurate? Those are the things that you would question, you would go back, build the model, experiment, and that is the reason why this is the whole research project. Compared to the hackathon, where this angle is not there. In the hackathon, objective is given, you need to do this, you need to do that, you need to run the model, you need to get the accuracy, you need to interpret. That's it. There's no going back and forth, there's no looking at additional data, there's no setting up of the objectives, and all that component comes in this coursework, and that's why it's a bit different. Okay? These are general guidelines to begin with. Now, let's have a look at the document itself, which is available on My Learning, which also I have attached in your email. Now, let's see what are the things that needs to be done. First of all, let's look at the important aspects. 60% you already know that we need to do. Let's talk about the deliverable. Okay, so all of you know what the end result of the project is. There are two things that you will submit. What are the two things? PPT and recorded presentation, right? And again, PPT is not something that you need to dump everything and write the reports kind of thing. It's more about your own structure and what structure do you follow for the presentation. You can just upload the PPT directly. Just make sure that PPT has some screenshots of data IQ and, as an independent submission, it looks perfect. Of course, you are doing the recording, you are explaining, that's going to be in the recorded video. So no Word document, no PDF, nothing. It's just one PowerPoint presentation. It could be any Prezi, Gamma, whatever you want to use, you can use. Presentation as a deliverable and recorded video as a deliverable. In the recorded video, it is very important for you to switch between what you're presenting versus what you're doing. For example, you would have done the things in data IQ. You would have made the model, you would have done the flow, you would have done prepare recipe, you would have transformed data, you would have run logistic regression, you would have run decision tree. So as and when you're explaining, keep switching tabs, right? So let's say you're on slide number 3, and now you say, okay, I will now show you what has been done in data transformation. You switch tab, come to data, you click on the prepare recipe, show the steps. This is step 1, step 2, step 3. This is the data type that you changed. These are the additional data points that you got. This is how you treated the missing value. Show them inside the platform. Once that is done, come back to the PowerPoint presentation. Now you say, now is the time I applied AI modeling, and I use 2 algorithms for my case study. I use logistic regression and I use decision tree. Then come back to data. Show how you implemented logistic regression, what were the results. Show how you did decision tree, what were the results, what did you change, and so on. So your recorded presentation, you should keep switching between PowerPoint and the actual project in data IQ, which you have done.
So the recorded presentation should be of how many?
So ideally we say 20 to 25 minutes, 30 minutes should be maximum, a good enough time for you to explain. But again, no hard and fast rule. So we don't say that, okay, if you exceed 5-10 minutes, there's a penalty or something. It's your space to explain, and if you need 5-10 minutes additional, ideally 20 to 25 minutes should be more than sufficient for the recorded presentation.
So first is like, you will use the same data IQ that you're currently using, you mentioned that it will.
Oh, that's a good question. The same one that we are currently using, that will continue only for the hackathon, because we don't want the sharing of the work. So let's say if you are doing the hackathon, someone can get into your folder and then see what you're doing. So we don't want that. For the research, does not matter. Anyway, the data is different, everything is different. So even if you're using this, you should be using the one that you're currently using.
And second is like we did the like similar video presentation in another module.
Okay,
But then the upload is limited to 100 MB itself. So-
500.
Okay, so for this it might be.
Yeah,
Then what if it was 100 and then we had 8-10 minutes for recording, it was very difficult.
Okay, so in this settings, I've kept 500 MB, but there are a lot of other options also. Let's say your recording exceeds the size. What you can do is upload a Word document with the URL. So you can either upload it on YouTube or on Drive or OneDrive and then give the link. But it's your responsibility then to make sure that the link is public. So it's not like, oh, when I'm evaluating, I cannot have access because by the time we are evaluating, all of you will be at different places. So then to chase you, or your URL is not reachable, then you will lose out. So if you are uploading the link, it's your responsibility that it has public access. So better, just even share it with me earlier that I'm going to use this link. But mostly with 500 MB, yeah, that should be good enough. Yeah. So yes, Tamil. Any other questions so far before I show you the structure of your postcode? All good? No questions? Okay, let's move on. Okay, now let's have a look at what are the various elements of your research project. Number one is domain knowledge and your research. Now, what do I mean by domain knowledge? Which you can start now. So basically, you have got the data set. Now you try and understand what these columns are, what do they mean, read some reports to understand what is happening in that industry. So some of you have got social media, some of you have got airlines, some of you have got telecom. There are various industries, right? So start reading a bit about what those columns actually mean. How significant are they in predicting anything in that industry? Is there some additional data that you can merge with the existing data? Start reading a bit about whatever you have got and increase your knowledge in that domain aspect. That's number one. Number two is identifying the objectives, which I said is the toughest part. What are you predicting at the end of the day? And this is going to be a prediction AI based, right? Now, how I would advise against any setting up of the objectives, and listen to this very carefully. So let's say you got flight accident data, okay? And one of the objectives that you are setting up for yourself is figuring out how many accidents took place in the last 5 years. Do you think it's a good objective or bad objective? What do you think? Not a good objective at all. Why I'm saying not a good objective? Anyone can just take average and done and dusted, right? That's not an objective for which you have to do a whole lot of research. Okay. So anything like that. So for example, what is the relationship between, let's say, some fuel and flight accidents? Again, it's a very small thing. You can do simple correlation to understand, the thing, or pivot table maybe, and then you can give the answer. So if your objective involves simple calculations, simple BI, simple pivot table, that's not a research objective. On the other hand, let's say you're saying, if you give me the parameters of an airplane, and if you give me the wind pressure, if you give me the humidity, if you give me the temperature, can I predict if something will go wrong? That's an interesting objective. That's where some research is required, right? There is an AI predictive element in that. So your objective should be futuristic, not past data. If it is past data, you're doing BI. You're doing pivot tables, summaries, and all that, which you should do, but only to enhance your knowledge, not to achieve a certain objective. So be very careful when you set an objective. It should be a research objective. It should have a prediction element involved. Is that clear with everyone? And once you have your, the whole objective, then of course the whole idea of storytelling, understanding the problem. Also, even if your objective is futuristic, is it relevant? I mean, will companies really benefit if they do this kind of a prediction? Okay. Will the industry benefit? Will customers benefit? Will someone benefit from your idea? All that is part of this domain knowledge and research. Now, most important thing, how many objectives should you have? Okay. Ideally only one that you should be targeting. Now, another question that I usually get, which you will get after you do some algorithms, is how many algorithms minimum should be implemented? Now, I would say we recommend a minimum of 2 algorithms. Okay, and listen to this very, very carefully. We recommend minimum of 2 algorithms. Now, you could do these 2 algorithms in 2 different ways. You could have 2 objectives and you could do one algorithm for objective 1 and another algorithm for objective 2. Something like supervised learning for objective 1, unsupervised learning for objective 2. That is one way of doing that. The other way is, no, I stick to one objective and I will try 2 algorithms of supervised learning and then compare which one is good, which one makes more sense, why you should pick one algorithm, why you should not pick one algorithm, and so on.
So how many objectives can we take and how many algorithms?
That's the great question. So let me put the names to the algorithm. We started with regression, which I would not recommend using for the project because they are mainly for numerical values. In this module and in this research project, you will mainly look at categorical algorithms, categorical prediction, which I'll come to. Today's session will start that. So I would say your algorithms are 4 in number. Logistic regression, decision tree, then you have k-means, which is unsupervised learning, and probably one more variation of unsupervised learning. So 2 supervised, 2 unsupervised. 4 algorithms is what you are playing with. And I would say either one objective with 2 algorithms or 2 objectives with 1 algorithm each. That's how you should play.
For example, sir, we take 3 objectives and then for one objective we can look at algorithms for decision tree and third the.
You can. So that's a good question. Does it stop you from choosing more than 2 objectives? No. What is expected from the coursework is 2 algorithms. Keep that in mind. Now these 2 algorithms could achieve 2 objectives or the 2 algorithms could achieve the same objective. So even if you do one objective, you still can score the best grades. Even if you choose 3 objectives, you might still not score the best grades, depending on what the objective is, how you have done it, how you have interpreted. So minimum 2 algorithms is what we are expecting. Yeah, everyone? Yeah? All right. Now, what are the other steps? Now, all this is initial work, research, domain knowledge, objectives, algorithms, and so on. Then you come to data preparation. There will be missing values, there will be outliers, there will be data type transformation, all what we are already doing in Data IQ, cleaning, importing, merging, etc., is another part of your research. Then comes model implementation, which is whatever algorithm you have chosen, you need to implement that model. You need to run that model in Data IQ. That's part number 3. And part 4 is visualization. Now, either you can do some graphs that can help you with the hypothesis. Maybe you can do some pivots that can help you with the hypothesis. Maybe there could be some charts that could come after the model implementation. So you can present those charts. Anything with a visual representation of data, either before the modeling or after the modeling, that can help you in your analysis. That's your part 4. And essentially, these are the 4 things that you are doing for your research project.
So did you upload this on MyLearning?
It's also there in the attachment. It's also there on MyLearn. I hope all of you got the email, right? So the PDF is there and the dataset is also there. Yes, PPT in a separate link, recorded video in a separate link. Correct. Okay, now the most important part. Everyone, please have a look. How would you structure your presentation? And this is the most important. What do you start with? Step 1, step 2, step 3, step 4. The first thing is in your presentation, you should start with introduction and domain knowledge. Okay. And don't go for the boring introduction that airline accidents are so many so far. Introduction means your research introduction. Okay. What did you do from a domain knowledge perspective? What are your objectives? How did you come up with that objective? Who will benefit from your idea? What is the kind of prediction that you're doing? All that is in step number 1, which is introduction plus domain knowledge. Step number 2, data preparation process. Tell us, how did you do your data preparation? First tell us, then go to data IQ, show us where did you do, and done and dusted. Part 3, visualizations. Did you do any pivot? Did you do any graphs to understand your data much better? Was there any visualization that helped you? The variable hypothesis, if you remember the trio, which variables you think are important? What is the hypothesis associated with that? Data availability, etc. All that comes in part 3, which is visualization. Part 4 is your AI model. Now, this is where you run the model, you show us the process, how many times you ran, what did you change, what results you got, were you happy with the results, did you run it again? Show us the entire process of model implementation. Last but not the least, now this is going to be interesting. You remember the Carrefour example that we discussed, delisting the product, right? And if you remember, we were actually doing the entire AI life cycle. And the last step of the life cycle was converting your idea into a product. Okay. Now don't get afraid. Don't get intimidated. You don't have to build the product here. Okay. But you can propose an idea. You can say, I did all this. I did the AI modeling. I did everything. If the company wants to use it, they can use it in this way. And you can tell how that product would look like. If you are enthusiastic a bit more, maybe you can prompt Claude or GPT to just give you a prototype and you can show some screenshots. So I'm not saying it should be a functional product, but just tell Claude or GPT that, I'm working on airline data. I want to develop a portal where people can enter the model number, can enter the temperature, can enter this. There should be a button called predict. It will show the probability. It will show this. Give all the inputs that you visualize the product should be, and AI will give you a nice prototype, and you can put the screenshots of the prototype in the final step, which is converting your idea into a product. And that completes the entire life cycle. You started with an idea, you did the data preparation, you looked at the research, you did visualizations, you did model implementation, you saw the results, and you converted your idea into a product. And that will finish the entire research project. So it's not something that can be done in 2 or 3 days. You need to play with it over a period of time, get friends with your own data and think of it as your work. And you should be proud at the end. If you can make a prototype and if you have done the modeling very nicely, you are able to build something very, very significant. Questions now? No questions? I thought everyone will be jumping around. Yeah, tell me.
So the processing should be live.
Not necessary. So that's a good question. Should it be live? I know you are quite enthusiastic in building with Claude and GPT. If you want, you can make it, but there are no sort of extra points on that. So don't stress around, I have to make a product, I have to make a product. It could be as simple as screens. You can have 3 or 4 screenshots and say, this is how your product should look like. The whole thing is, are you able to visualize what kind of product can be built, right? And can you show us that this is your vision? It could be with screenshots, it could be with a live product. If you want, you can build it. Why not with a link that say, you try and actually build this? So up to you. But no extra credits, it's just the way you want to express your final idea.
So we can add this in the resume.
100%, 100%. And this is what, when many people ask about job search and all that, I would say if you own your projects, you create visibility, you go to LinkedIn and say, I did this and, this was an innovative thing which I tried and so on. So this adds to your resume 100%. It's a full project that you are building end to end on a live industry data. Any other questions? No questions? Sorry?
Questions will come when we start.
Yeah, I 100% agree. And keep this in mind. So with every class that we meet, keep on asking questions so that others can also benefit with your questions. And then, of course, what I can also do is before you submit, I'll create a draft version also, not of the recorded presentation, but at least of the PPT so that I can see what flow structure you're using. And if you're going extremely in wrong direction, I can alert you. And I would say this is not of the quality that we expect. So we will have a draft link where you can have one feedback before you actually submit your paper. Okay. Last but not the least, the marking criteria is given, standard. It's basically if you have done everything. So your presentation overall is 40 marks, introduction, domain knowledge, data preparation, model, visualization, product. So standard marking, basically checking all the lists. So it's a collective project. So on paper, we do put some marking criteria, but overall, we see the whole cycle, the whole pipeline. Okay.
We will use screenshots.
Correct.
But with the prototype before one more thing I wanted to add, can we use the Power BI dashboard as screenshots in order to?
You can, but the thing is, you're anyway using data IQ, so and it provides the same charts functionality. But if you're more comfortable building a dashboard in Power BI, no harm. So we are not, sticking to one tool per se. Whatever suits you, but since everything is already happening in data IQ,
But sir, we can definitely an API for Power BI and integrate into the.
you can, why? So if it suits, if you're more comfortable, fine. Any other questions, guys? Anything on the course form? Shall we move on to logistic regression? Yeah? Okay. All right, so let's get started with the official first algorithm for the prediction world. Second algorithm, we have already seen regression as one of the foundational algorithms. And before we switch to logistic regression, you need to understand the differences. Why now one more algorithm? When you can already predict with regression, why do you need logistic regression as a separate algorithm? And are they substitutes of each other? Can regression and logistic regression achieve the same purpose, or are they actually meant to do different jobs? And how does it do differently is what we are going to see today. Let me do a quick recap. When we did regression, was that pure AI or machine learning? Machine learning, because historical data was there. When we did the final prediction challenge, was it supervised learning or unsupervised learning? Supervised learning, 100%. There was one variable that you were predicting. And what was that one variable in the final prediction challenge? What were we predicting? Sales, right? Sales of a company. That's the variable. And which variables were helping us predict sales? Week number, right? Nothing else. We just took one on one. Hence, we didn't have any other variables which were helping us predict the sales. Now, I will continue regression itself a bit before I move on to logistic regression. And please observe this carefully. I'm going to ask you a lot of questions. Now imagine, and this was, actually one of the case studies which we did with Majid Al Fateh. So, the idea was whenever a new tenant comes to the mall, we used to predict the revenue of a tenant for the next 2-3 years. You would ask, why do you want to predict the revenue of Starbucks coming to Mall of the Emirates? The reason is, all your mall, they share a percentage of revenue to us. I mean, the logic is you're in the mall and your footfall is your footfall, but you are getting additional footfall because of the mall, right? And if you're getting additional footfall because of our initiatives, we need some percentage in that. And that's a standard practice in all the malls. But the problem is, some tenants were not happy when they were not doing well. So they would say, look, I'm already doing bad. There are no customers and I'm paying you 20% of the revenue, which is not fair. On the other hand, on the other hand, some tenants might be doing extremely well. Okay, they are minting money because of the footfall, and they are paying only 5%. And we would say, what if it was 7%? What if it was 8%? It would have been great for bank. So what we did started doing for every tenant based on the location in the mall, we started predicting how much they will make in the next 2-3 years. And based on that, we used to charge a percentage of the revenue. Okay. Now, answer the following questions. Is this use case supervised learning or unsupervised learning? Think again. Why? Why supervised? Why unsupervised? Tell us why supervised? Only targeting revenue. That's it. That answers your question. You are predicting revenue. Everything else, the position in the mall, the brand equity, the existing number of competitors, category performance, economic indicators, they are all helping me predict that single variable, which is revenue. Again, one variable that we are targeting, perfect example of supervised learning. Everything else that is helping me predict that revenue is X1, X2, X3, X4, X5, X6, X7. And this is basically your case study, your research project. If you can figure out what you're predicting, which is the objective of the use case, half of your job is done. Then you figure out which variables can help you predict that variable, which is X1, X2, X3, X4. The other half is done. And that's where the toughest part of your project is, to find out what you're predicting, to find out which variables can help you predict that one variable. Okay. Now, imagine we did this. Okay. I ran regression. Regression is a suitable algorithm. I'm predicting revenue, which is Y. Have a look at the equation. Okay. I'm predicting revenue, which is Y. Let's assume I have taken 4 variables. X1, X2, X3, and X4. X1 is brand equity, which tells how strong the brand of the tenant is when they are coming to the mall. X2 is number of competitors. X3 is distance from the anchor stores. Basically, how far away are you from the hotspots of the mall? And the idea is, if you're very far away, you might get less footfall. If you're closer to the hotspots, you might get more footfall. And X4 is previous sales of the tenant. So if Starbucks has already been doing well, there's very high chance that they might do well when they come here. Ideally, we would follow the same process of hypothesis, which will affect how and so on, data availability and all that. Imagine we did everything and we ran the equation. We ran regression. We actually ran regression, by the way. And we got a result like this. Okay. Now, math is asking you, good job. You ran the regression. Let's assume, things are looking, R-square value is looking good. Let's say it is 0.85, which means you can trust the equation. That means you are ready to predict. You can say, okay, tell me the brand equity, tell me the existing number of competitors, tell me the distance from the store, tell me the previous sales of the tenant. I can predict the revenue of a new tenant. Very much possible. Put the value of X1, X2, X3, X4, get the value of Y. That's how you use it for prediction. Now, answer this question. Math is asking you, you took 4 variables, okay, for helping you predict the revenue. Which out of the 4 variables is the biggest impactor on revenue? How would you answer that question? Which variable out of the 4 is the biggest influencer in predicting the revenue of a tenant? Previous sales, he says. Hotspot, he says. Have a look. Which one is the biggest influencer in predicting the revenue? Brand equity? Others? In order to answer this question, you need to understand what those numbers mean. Okay. Let's see what this 2 means. What is -3? what is 4, what is 5.5. These are 4 numbers that you have to be careful about. Let's talk about X1, which is brand equity. Okay. Can anyone tell me how do I interpret that number 2? How do I explain it to math? What is 2x1? Sorry? What is 2x1? How do I explain that 2? You can see 2x1. X1 is brand equity. Y is revenue. Now, how do I tell to math? Revenue is always double of equity. Equity is the double of revenue. Okay. Anyone else? Keep guessing. This is how you maths become quite interesting. How do I explain it to math? 2x1.
The brand in 1 unit.
Okay.
The revenue increases by 2.
That's a better explanation. Now, everyone, please listen. What she said. When the brand equity increases by 1 unit, the impact on the revenue will be, it will become double. Which is right. So I don't know what the unit of brand equity is. Maybe it's a scale of 1 to 10. So if the score is 4 and I change it to 5, provided other variables remain constant, then the revenue is almost getting doubled up. That's what plus 2 means. If that is plus 2, can anyone give me an interpretation of number of competitors? Anyone else? More the number of competitors, lesser would be the revenue. And if they ask how many times less? 3 times. One increase in one competitor will result in reduction of revenue by 3 times. That's how I read -3. Similarly, +4, which is distance from the anchor store. As your distance from the anchor store increases, then the revenue increases 4 times. Now, this is where you would think, is that logical? Is that not? And that's why hypothesis is important. In your hypothesis, you said the more away they are from the anchor stores, lesser should be the revenue. But now you got something opposite. Is it truly opposite or you made some mistake? That's how you go back and check. Similarly, 5.5. As the previous sales increases by 1 unit, the impact on the revenue is 5.5 times higher. Independently, if we compare X1, X2, X3, X4, which one do you think has the highest impact on revenue? Positive or negative combined? Previous sales, which is 5.59. So it's one of the biggest influencer in predicting your revenue. Of course, you need to look at another mathematical parameter in regression called p-values, which tells you whether they are significant or not. But otherwise, these coefficients tell you the importance of the variables. Good news in data IQ, you don't care. I mean, the tool is quite amazing. So what it does, it looks at the coefficient, it looks at the p-values, it looks at everything for you, and it gives you a nice visual. And it will say, of all the 10 variables that you consider, these are the top 4 that are predicting your whatever you want to predict, right? And it will also order them. Which one is most important, which one is less important, and so on. It will give you a perfect visual summary and everything, which is the greatness of the platform. In a coding world, you would have scratched your head on, okay, where are the coefficients, where are the p-values, and you run another code to, order them in a sequence, no visuals, no graphs. But in data IQ, when you run the model, it will tell you. It will tell you A to Z of which variables were important, which variables were not, which is most impactful, which is less impactful, so that you can make your model much, much better. This is so far a regression. Now, same thing applies in logistic regression also. Please listen very, very carefully because this would help you understand why do we need logistic regression. Exactly the same thing applies in logistic regression, which means you're predicting something that becomes your Y. There are lists of independent variables, which is X1, X2, X3, X4. Exactly the same thing. There is only one difference on why we choose logistic regression instead of regression. And in order to answer that question, I will ask you another question. In regression, what do you think are the allowed data types for x1, x2, x3, x4? And let me give you some options. Can I have any one of the x1, x2, x3, x4, x5 as a text variable? 100% not, out of question. So for example, if name is one of the variables, you can't put name in x1, x2, 100% string text is out. Can x1, x2, x3, x4 be a categorical variable? Can any one of the x1, let me give you an example. Let's say instead of taking previous sales, can I take a variable which says good sales or bad sales? You can? Absolutely yes. Any one of your x1, x2, x3, x4 can be a categorical variable. It can be a binomial variable like good or bad. It can also be which group the tenants belong to. Is it group 1, category 2 or category 3? 100% allowed. No problem in regression. Which means your x1, x2, x3, x4 can take categorical variables, can take numerical variables. 100% numerical also allowed. What it cannot take is a string. Now let's come to y, the dependent variable. Now, can that be a string? Can you predict the text? What do you think? So for example, there is a column called name. Can you run a model that can predict name for you? 100% no. That's weird kind of a modeling. Can that y be numerical? An actual number? What do you think? Yes or no? Can the y be numerical, an actual number? Yes, 100%. That's what we are doing. Revenue of a tenant is an actual prediction. Sales, which we did last time, is an actual number, right? All what we have seen so far, there is a numerical prediction. And now the most important part. Can that y be categorical variable? Let's say you want to predict whether a country will win a match or not. Unfortunately, not. And that's where regression says, thank you, our relationship was only till here. Now you want to do a categorical prediction? Goodbye. I cannot do categorical prediction for you. Regression cannot tell you whether some country will win a match or not. Regression cannot tell you whether it will rain or not. Regression cannot predict whether you will pass or fail in an examination or not. The moment categorical predictions comes in, regression says, done and dusted, my job is done. I give this job to logistic regression, which is where there is a set of algorithms that can do categorical prediction for you. Now, this becomes very, very important. Whatever you are predicting, if it is numerical in nature, regression can do the job. Okay. However, if you are doing a categorical prediction, which is where most of the AI world today is doing, the prediction of good or bad, the prediction of sales, good or bad, whether it will rain tomorrow or not, whether a customer would default a loan or not, whether an employee will leave the organization or not. Majority of these categorical predictions are not done cannot be done. Not that regression should not do, cannot be done by regression. And there is a reason why regression cannot do. I'll show you the reason. Let's have a look. So we did all this. 1 minute. Okay, everyone, have a look here. Why regression fails? Have a look at this graph and let's circle back to our last class. In the last class, we did regression, right? What were the two variables over there? What were we predicting? Sales. And what was the other variable? Day number or week number, right? What we did, we said first plot the X and Y, okay? Find the best fit, which is the trend line, which can connect all the dots together, get the equation of that line, and then and dust it, right? Let's apply the same logic here. What difference do you see between this X and Y? So by the way, income is on the X axis and whether a person will vote is on the Y axis. Okay. On the X axis, it is income. And on the Y axis is whether someone will vote or not. And that's what you're predicting. Whether someone will vote in an election or not based on the income. Now, what do you think is different of this graph compared to what we did earlier? Why?
What's that in computing regression?
Exactly. Now have a look here. So some of the dots are here and the other dots are here. Now what line are you talking about? What trend are you talking about? What exponential, what polynomial, what linear? There is nothing in the world that can in any way connect, all the dots even close by together. That's why regression says, sorry, the line of best fit does not exist when the data becomes categorical. When it is not categorical, it is numeric, I can fit a line for you, I can fit a trend for you. But when it is two opposite poles, I'm sorry, I cannot fit anything here. You need a separate maths altogether. And hence the maths of, odds ratio comes in and logit and log of odds ratio and all those drama came in order to give birth to another algorithm, which is called logistic regression. However, you need to be a bit careful when you do logistic regression. So let me come to this and don't get intimidated. I'll just tell you one thing. You saw the equation for regression, y equal to something x plus something x plus something x3 plus something x4. That's how regression, linear equation looks like. A logistic regression equation looks something like this. Log of odds ratio. Okay, so odds ratio is the odds of winning the game or odds of getting a bad mark, odds of losing a game, odds of raining tomorrow, categorical prediction. Log of that whole bracket is odds ratio equal to something x1, something x2, something x3. Question to you. Which side of the equation resembles regression? The right side is exactly the same. Something x1 plus something x2, which means everything is the same. You identify x1, x2, x3, it will give you a relationship. However, there is one major difference. In regression, when you put the value of x, you get the value of y. In the previous example, you put the value of x1, x2, x3, x4, you get the value of y. That's what you were predicting, right? You're predicting sales, you got sales. Here, when you put the value of x1, x2, x3, x4, you don't get y directly. You get the log of odds ratio of y, from which you can calculate probability of y, and from that probability, you can decide whether you consider this as win or lose, whether you consider this as rain or not rain, whether you consider this as default or not default. Algorithm does not directly predict that. It gives you a probability. Now you put a benchmark to the probability and you say anything above 0.5 is I consider yes, anything below 0.5 I consider no. So remember, logistic regression never predicts directly. It only gives you a probability, which is great in a way, because imagine you're a bank manager. A customer is coming to you applying for loan. At one end, you're saying, oh, I am seeing only two results, whether this customer will default the loan or not. At the other end, you're getting a probability. You're saying the probability that this customer will not pay back the loan is 0.9. It's a very high probability. Versus another customer coming and saying the probability is 0.55. There is a difference of this customer versus that customer. So as a manager, you take better decisions. Maybe 0.55, I would say, maybe I'll approve the loan. But 0.95, I would say there's a very high chance that the customer will not pay back the loan. So I can take a decision of not approving. The summary of all this is two things. Whenever you're doing a categorical prediction, go for logistic regression. Whenever you're doing a numerical prediction, go for regression. Everything else remains the same. Major difference number two. In regression, when you put the value of x or x1, x2, x3, you get what you're predicting. In logistic regression, when you put the value of x1, x2, x3, you don't get directly whether someone would pass or fail the exam. You get the probability of passing the exam, from which you can decide, do you consider this as pass or fail? Again, the good news. Data IQ takes everything off from you. Says don't worry about log of odds ratio and probability. It says if you want, I can give you. If you want to see the probability for every customer, I'll show you the probability of loan default. But what I will do is I'll assume 0.5. Anything above 0.5 is yes. Anything below 0.5 is no. I can give you direct predictions. But that does not mean that the algorithm is giving you direct predictions. It's giving you the probability. That's what the algorithm is designed to do, to give you a probability, and then based on that, you decide where it can go, here or there. Also, one important piece of information, logistic regression not only predicts two categories, it could be multiple categories, right? For example, there is a customer loyalty program of gold, silver, and bronze. A new customer is coming in, and you want to predict eventually which category this new customer will belong to in future. It could be gold, it could be bronze, it could be silver. There could be three categories, two categories, does not matter. If it is categorical prediction that you're doing, then you are going for logistic regression. Don't get disheartened by the maths of it. As I said, the tool is phenomenal. It takes away everything. You don't literally put the value of x1, x2, x3 and calculate the equation and all that. Everything is done by the tool. It just says, do you know what algorithm you are applying? That's it. I will help you with everything else. It will also tell you which one of the x1, x2, x3, x4 are the most important variables in predicting what you are predicting, which one is positively affecting what you are predicting, which one is negatively affecting what you are predicting. Everything the tool will visually compute for you, but essentially it's all coming from this equation.
Does the whole logistic regression process?
Very good question. So for both of them, essentially the same. So the constant is the constant value in regression. Constant is also the same in logistic regression. It essentially gives you a starting point, which means if all the independent variables are zero, what does the predictor look like? So it's the slope that it gives, and it's the same interpretation. Oh, good question. Any other questions? If not, I'll ask you a couple of questions before we take a break and get started implementing logistics failure. No questions? Okay. What I want you to do is give me some realistic use cases of logistic regression other than the ones that I have mentioned. So I have mentioned loan default, yes or no. I have mentioned you pass or fail in an examination. I have mentioned whether it will rain tomorrow or not. It's a categorical prediction. Other than that, can you give me some realistic categorical prediction?
Piece of petrol.
Very good. Classic case, you have all the historical data that you need. Would next month lead to an increase or decrease? That's what you're predicting. Fantastic use case. What are the variables that can help you predict? Historical data, of course, historical prices. It could be, let's say, the current economic conditions. It could be buying behavior, the existing population or the number of people who have traveled versus not. All these are X1, X2, X3, X4. Why is whether it will increase or decrease. I love that use case. Anything else? Elections, whether someone would win an election or not.
Pricing of goods due to war.
Fantastic. Now you are trying to see the impact of regional situation on increase or decrease in prices. So two categories, will it go up? Will it go down? Stock market is a classic example. Every up and down is logistic regression, decision tree. These are all the algorithms which are working at the back end to predict whether stock prices would go up or down. Anything else?
Gold price.
Gold price, 100%, will it go up or down? And again, you can have timed intervals. Are you taking day level data? Are you taking hourly data? Are you taking this? And accordingly, you can predict whether it will go up or down. So anything categorical in nature is something that you can use logistic regression. And why this is an important piece of information is now you can go back and look at the data that was assigned to you. Look at all the columns. And you can say, oh, is there anything categorical in this? Can I have some categorical predictions? Don't have a look at it now. I'm just telling you can have a look. One final question. Let's say the data set that I give you has no column which is categorical in nature. Everything is numerical, let's say. Can you still apply logistic regression? How?
If there is a futuristic value you want to predict,
Hmm.
like there's no column that says, it's categorical. But then if you want to predict something that you think is a yes or no, or it is
Correct. That's a good point. But the problem with that approach is anything that you want to predict, there has to be a historical data for that. So if you want to predict yes or no, there has to be some yes or no from the existing data that it can learn from. And this is exactly my question. You don't have any categorical values. Can you still predict something categorical? What do you think?
So is it necessary for the historical data to be there?
It has to be. That's just machine learning. That is machine learning. Think about this. No? Take a guess. Yes or no? Can we predict categorical if there is no categorical in the data? Okay, let me. How many of you got airline accident data? If you have checked your data already. One. Okay. Now let me give you an example. Let's say, and please listen very carefully because this is applicable in all your things. Or even better example is carbon emissions. There is one sustainability data as well. So imagine there is one column which is actually the actual carbon emissions. Okay. And now I'm looking at that column and I'm saying this is a numerical data. I cannot do categorical prediction. However, I can look at that column and I can say, okay, the average carbon emissions are 20,000 in that entire column. What I can do is I can convert that column into categorical. And I can say, if the carbon emissions are greater than 20,000, then it is bad, else it is good. Which means I did not have it, but I made it. And now I'm predicting that a future company which has this, whether they will have good carbon emissions or whether they will have bad carbon emissions. Absolutely doable. Same case with sales data. You have the actual numbers and you can create three categories of sales. Anything above this is excellent. Anything between this and this is medium. Anything between this and this is poor. Now we have three categories. Excellent sales, medium or poor. And now we are saying, I will do a prediction for the company that next year, will it be average, will it be excellent, or will it be poor? Fantastic example of logistic regression. So even if you don't have a numerical data, does not mean, and in fact, many companies prefer categorical prediction because numerical prediction is to get it right is very, very tough, right? To get the exact sales for next year, very hard to have a very close number. So they would say, let's create categories of sales instead of exact sales number, whether we'll be grade 1, grade 2, grade 3, or grade 4, first convert it and then predict it, which could be very well done in your use case as well. Okay? Any final questions? After we come back, all data I give. I'll give you a superb data set on Titanic's survivors when the disaster actually happened. And we are about to build a model on whether a passenger could have survived that disaster or not. So something which is considered the Bible of AI predictive modeling. Okay. Any other questions? All right. So the time is 10:40. Let's come back at 10:55. 5 minutes to 11. Okay. Thank you.
Hello, sir.
Sorry. Yes. Go ahead, please.
My apologies. I just had one question.
Yeah.
See, we have like around, I think, 13 students who are
Mhm.
attending online today.
Okay.
How many of the students in the class are attending physically?
So around 30.
30.
Yeah.
So
So there are
that means
45.
45. Okay.
Yeah.
All right. All right. Thank you so much, sir.
Okay. If all of you can sign into My Learning, please. My Learning, keep data IQ ready. Let's start. So your step one should be to download a file called Titanic 4, not unknown Titanic, unknown will come later. Titanic 4.csv, which is in week 5 folder. That's the one that you'll be downloading for the data. And then keep data IQ ready. And then we'll start together. For data IQ, always remember, scroll all the way down, check your folder. Inside your folder, click on new project and then give it a name Titanic and then start, because we'll be continuing the same next class also. So you need to make sure that you know the folder as well as the project name. It is Titanic 4, Alicia.
Okay,
Not
sir.
unknown Titanic, yeah? So I'll give 2 minutes for everyone to do the following. Download Titanic4.csv from your week 5 data, and then keep your data IQ ready. And if you have downloaded in Data IQ, as I said, please remember your folder. So just scroll down all the way, find your folder, and inside the folder, make a new project called Titanic. And what you can also do is import your data set, which is Titanic 4. Keep it ready on your screen so that I know everyone is ready to start. So you know how to import now. This should be very basic. Coming. So that's Titanic 4. Yeah, so this is where you should be. Your Titanic data should be loaded. Any questions? Which one? Student. So the problem is there was we all are working on the same platform for sure. Yes, upload it please, and if you want, you can give it a name, or you can retain the same name. And keep your data ready. I can see two of you are ready. Yeah, this is how it should look like. Your Titanic data set, and then we'll start together. Please keep the data screen ready on your screen so I know. Those who came late, it is week 5 Titanic 4.csv and import it. Great, yes. Great, I confused where you put it. Just search, yes. No, you're on Google. Yeah, this is your. And these are the two things. Now, pay the new project. So you name it Titanic itself. You too. Yeah. There are no projects. Make something like. Make it outside. Now, no. If the name is conflicting, just give another name, Titanic 56 or something for the project name to be unique. Yeah. Not today. Yeah, fine. Yeah, fine. Tomorrow night. And we have changed the venue by the way. So it should be now. I'm sending it. This should be basic now. These should be quick. All good, all good. Anyone still needing help? Okay, now let's get started. Everyone, imagine this is your data set for everyone. Pay attention, please. Imagine this is your data set for your coursework. Now, this is where I will tell you the difference between hackathon versus your coursework too. Okay. Today's session will be more like hackathon, where I will tell you the objective of what needs to be predicted And we wouldn't do much of research. We wouldn't add something, bring additional data points and domain knowledge and all that. We wouldn't do so much. This is more like a hackathon where the objective is to develop skill in making an AI model. I don't think by the end of the session today we'll get to the AI modeling part. We should most likely be doing the preparation part and pivot tables and all that. And in the next session tomorrow is when we would get into the AI recipe, where we will do a train test splitting and then we would run logistic regression, see the results, get the probability and understand everything. So that's going to be the second part. However, going forward, the next algorithm, we will not be spending 2 sessions for one algorithm. I'll tell you what the algorithm does. We'll give you the data set. For example, in decision tree, we'll be taking the credit card data and we'll be predicting if a customer would sign up for the credit card or not. And that should be quick after you understand the process, because the process remains the same for the other algorithms. So have a look at the data. The first column, what do you think that first column is? And what is that? 0 or 1, whether the passenger survived or did not survive. Okay. Now, usually I begin by looking at each row. I would say, what is represented in each row? In row 1, row 2, row 3. What are these rows? The passengers. Passenger 1, passenger 2, passenger 3, passenger 4. For every passenger, I have some information. The first column says whether the passenger survived or not, 0 or 1. The second column says passenger ID. What do you think the third column is? The class in which the passenger was traveling. Now, everyone, pay attention here. I'm just correlating to a hackathon or your coursework. Let's say I don't understand what is P class. Okay. Now, in coursework, I would go and do a bit of research. What is P class in a ship? Let's say if I was doing this for research, I would think, okay, what was the design of the ship? Where was class 1? Where was class 2? Where was class 3? All that comes as part of your domain knowledge. I'm trying to understand a bit more better on what's happening in that class. That's where I'm increasing my domain knowledge. Then you have gender, age, I think pretty much all self-explanatory. The ones which are not self-explanatory is something called SIB-SP. Now, let me tell you what this column is. It is the number of siblings and spouse that are traveling with this passenger. Okay, the total number. So let's say there are 2 siblings, 1 spouse. So total 3 would come in that column. So SIB-SP is number of siblings and spouse that the passenger is traveling with. The next column to that is SPARCH, which is number of parents and children that the passenger is traveling with. Okay. So whatever number you see here, if you see 2, that means total number of parents plus children equal to 2. What else? Ticket ID is there, fare is there, cabin is there, self-explanatory. The last is which port they embarked from. So there are 2 or 3 ports where they embarked from, and that would give some idea. Now you tell me, what will be the first step that you would do? Come again, what was your point? Cleaning will come a bit later. What else? That is part of the clean, missing values will come a bit later. Imagine you are doing your research project and you import it in data entry. What should be the first thing you should ideally be doing?
We'll go through the.
That's right. Schema also comes a bit later. First is go through the data and get some more understanding. And what is that one button which can give you full snapshot of what is happening in your data? The analysis is only for one column. Quick column stats. So that's where you do last, and I really want you to do this because that would give a super picture of every single column in your data. For example, let's look at the survived column. Okay, and if you see, the 0 is 549 and 1 is 342. You can keep your mouse pointer, by the way. And that means 549 passengers did not survive. And see the last graph, 342 survived. And there is one more piece of information. If you see the graph, other than how many survived and did not survive, you are getting one additional piece of information, which is the data type is not great. You see, the graph is pretty bad. Even though it tells you how many 0 and 1, it does not say 0 so many, 1 so many. That means something is wrong in the data type. And we can immediately figure out what is wrong. Let's see what happens in survive. So let's go to survive. Sorry. So tell me, what is survive initially stored as and interpreted as, and what's the problem? It is stored as a string, which is okay. I mean, ideally you can do Boolean also because it has only two values. But the problem is interpretation as integer. And why do you know this is wrong? This is absolutely wrong. Coming back to bank data where we saw zeros representing something else. Here, 0 does not mean a numerical value 0. 1 does not mean a numerical value 1, right? 0 means something, 1 means something, which means if data IQ is interpreting that as an integer, there's a problem. It is still a string, right? It is still a category. So let's change that integer to string or text, interpreting as text, and then do quick column stats. And now it makes sense. Now the graph is quite good. So now it says 0, 549 and 1, 342, which means 549 did not survive. 342 survived in the disaster. What else? P class. P class is also pretty bad. Actually, there are three classes, 1, 2, 3, but I can see the x-axis is looking very bad, right? So what can I do for P class? Same thing, absolutely. So the interpretation should change to text. And now it's beautiful. There you see, 1, 2, 3. So again, see how much quickly am I gaining knowledge about data, right? I didn't do anything. I just look at P class and I can see majority of the passengers are in which class? Are they in class 3, 2, or 1? 3. And see, without even knowing what is class 3, what is class 2, what is class 1, you can immediately infer that 3 should be economy and 1 should be the best class. So 3, 2, and 1, I get the absolute numbers, 491 in 3, 216 and 184 in 1. Does gender look okay? Yeah, it is perfect, male and female. So more males or more females on board? More males. See, I get age distribution. I can see which looks okay. Pretty much normal distribution. SIB SP. Do you think SIB SP, the graph is problematic? Now, this is where we need to be careful. Now, imagine, although the graph can be made better with the x-axis representing closer values, but actually there is no problem in SIB-SP. Let's go and check. What is SIB-SP? It is stored as string, interpreted as integer. The only thing you can do is say it should not be stored as string. Interpretation is right because these are not categories. These are actual numbers. Number of siblings plus number of spouse, right? So it's a numerical number. It can be 3, it can be 5, it can be 7. It could be anything. So that numeric is numeric. It does not mean category 1, category 2. So I will leave it as it is. If you want, you can make the graph better, but I should be okay with that. What else? Embarked look okay. 3 categories. Yeah, so some quick checks on the column and I get to understand data a bit better. Number of parents and children. Total, again a numerical value. So ideally, if you want, you can change the stored data type from string to integer also, does not matter. But as far as things are working, we will keep it then and there. What else quickly can you learn about the data? There is the green bar and the red alerts can give you something. So what about the green bar? What are the problematic columns that we have? Age. You see, there's a significant amount of age
Yeah.
which is missing. So I need to take care of it. What else is a problem? Cabin, yes. Law cabin, in fact, majority is missing. So it would be disaster if I take cabin for any of the analysis because only minority data is available and majority is missing. See how quickly I'm getting all this information, right? Because of the visuals. Embarked also slightly, I think there's some gray at the end. Yeah, and we can see that in the column analysis, how many are missing. So embarked sum is missing, age is missing, cabin definitely a very bad variable. You see some reds here. That's because the interpretation is integer. This is basically ticket ID. So should the interpretation be an integer? No, I mean, these numbers don't make sense. These are IDs. So in case you want to get rid of that red, you can make the interpretation as text and that red is gone at least. So few changes I have done. I'm getting ready for my analysis. Any questions so far on missing values? I had some interpretation, some understanding of data. Is everyone okay with me? Correct. So now if either now there could be two things. Great question, everyone. Forgot your name, sir. Akash. Akash, yes. So Akash is asking there is decimal in age. Now it could be an error, or it could be that the months were sort of represented as decimal value. So we don't know. We'll assume, okay, dot will not make too much of a difference. So let's keep it decimal. But if you come to know it is error, then you should remove the decimal point and you should consider only the main page. So we don't know how the original data was being fed. So we give that as a benefit of doubt. Okay, good observation though. Now, everyone, pay attention. Imagine this is your hackathon versus this is your coursework. If this is your coursework too, you don't have an objective yet. You don't know what you're doing with AI, right? Which means you come up with your own objective. You come up with your own prediction. What do you want to predict? If it was a hackathon, it is given. And let me tell you, this is a hackathon style. So I'll tell you what the objective is. The objective is to build an AI prediction model that could predict the survival of a passenger. Okay. How does it look like in the long term? Once your AI modeling is done, I will give you a new passenger that never existed in this data. I will tell you the age of the passenger. I'll tell you the gender of the passenger. I'll tell you the class of the passenger. I'll tell you SID-SP. I'll tell you PARSH, etc., etc. I'll give you all the information about the passenger except for one thing. What is that one thing? Whether they survived or not. And what you need to do, you need to say, okay, thank you. I have this information. Let me put it in. Let me put the gender. Let me put the age. Let me put the class. Let me put SID-SP PARSH. My algorithm will predict whether the passenger would have survived or not. Or in future, if there is a disaster like this, will the passenger survive? Yes or no? Question. When you run algorithm to predict whether a passenger will survive or not, will the algorithm directly give you the answer yes or no? Or will it give you something else?
Yes, sir.
Think again. It will give you the probability. That is very important. In data IQ, you will get a prediction, yes or no. But what data IQ does is it looks at the probability. Any probability greater than 0.5, it will assign it as survive. Anything less than 0.5, it will assign it as not survive. But you as an analyst need to know. Algorithm didn't tell you yes or no. Algorithm gave you a probability and it's up to you whether you want that benchmark to be 0.5, 0.55, 0.45, 0.6, depending on the use case, you have the right to change that benchmark. By default, the tool will take 0.5. Anything above 0.5 is this, anything below 0.5 is that. But it's up to you. As a decision maker, you must see the probabilities and then think of whether the prediction is survived or not survived. So far, so good. Now, let's start with the AI analytics lifecycle. My objective is clear. I've done some domain knowledge. Now is the time for the trial. Variable, what was the trial? Hypothesis, data availability. Now, in this case, because this is hackathon style, I'm not looking at any external data or anything else, but in your project, you can find more data points. If you can add more columns, you can generate more columns, you can all do that. But here, let me go column by column, and you will help me prepare the variable, hypothesis, and data availability is common, so only variable and hypothesis. Let's get started. We'll go column by column, and I want everyone to participate. Who do we start with? Someone that if not last. Your name? Adarsh. Adarsh, one question and tell me a yes or no. I'm looking at passenger ID as one of the columns. Do you think it is worth considering passenger ID as one of the variables that can affect survival? I think passenger ID can affect the chances of a passenger surviving or not logically. Now, this is where domain knowledge is happening. What do you think? No, 100%. I mean, your roll number will not affect whether you would pass or fail an examination, right? Roll number ID is an ID, it could be anything. So 100% that ID column today is irrelevant for my exercise. And this is how you save time. And observe carefully because these are the steps for the hackathon as well as for your coursework. The moment I see ID, I would say, for my use case, I'm never going to take ID. Okay. Now, how does it save time? Now, whether the data type is correct or wrong or interpretation, I don't care. Whatever it is, I'll just leave it. So I'm not going to consider ID as one of the variables that would affect the survival rate. So it's out of my variable. It is never going to be an X1 for me. I have to hunt for new X1, new X2, new X3. Let's move on. What's the next column? P class. Who do I check? Kartika, right? Yeah, Kartika, tell us, do you think P class could have an effect on survival, which means whether the passenger was in class 1, class 2, class 3, would that have decided whether they survived or not? Yes. Logically, yes. And what is your logic? Why do you think? Right.
There can be chance for a people in a specific class to reach out to the safer side.
Very interesting. So your logic is the design of the ship, right? So based on the classes, on whether it is at the bottom layer, mid layer, or whatever, there could be easy access for the safe zone, and hence there might be a possibility. What is other logic?
As passengers because the personal got a opportunity.
Got a preference. That also could be possible, right? Now, hypothesis is building, right? Now, you're saying the design of the ship would be in such a way that, some people survive, or maybe there was a preference given to class 1 compared to class 3. Now, I'm coming and saying, no, there should not be any effect of P class. And let's say we have a debate over this, whether we should consider P class or we should not consider P class. You think you can do at this point of time? And there is something that you can do. Sorry? How? What will you do now?
If the numbers we have,
Correct.
the major people are from the future.
Yeah.
That your data says that the major number are coming from.
But how can I see that data more clearly? Pivot tables. And this is exactly what we are going to do. And you will see how beautiful pivot tables are. Now, sitting at this place, you don't know what happened in that disaster. You don't know whether preference was given, but you can start understanding some things. And this will also help you build hypothesis. This will give you a trust that P class can be taken as one of the variables which would impact our survival. Let's do it. Let's make a chart. So get to the charts column. And let's do it together. This one, next one, you can do it yourself. So let's choose pivot tables. Now, let's say I put P class in rows. What do you think should come in columns? Survive, very good. Survived in column and the count in value. This is giving you something. Once again, P class in rows, survived in columns, and count of records in value. How do I read this is very important. How many total passengers were there in class 1? 216. And how many of them survived? 136, which is a good number of survival that you're looking at. As compared to class 3. How many total in class 3? 491 and only 119 survived that. So which means if I don't take P class, it will be a crime. It is one of the important indicators. And hypothesis is saying that if you are in class 1, you have higher chances of survival compared to class 3. This is what my initial hunch, this is what my data is showing, and this is what logic could also show. So all things are pointing towards the fact that I have something interesting here. Okay, coming back to explore. Let's move. What about name of the passenger? So two questions here. Do you think technically we can take name as one of the independent variables? No, it's a string you cannot take. And logically, should we take name? No, unless you believe in, I don't know, if your name has some characters, then you will survive or not. If you want to test that theory, you can convert this into number of characters in the name, or maybe one of the more logical things which people have also experimented. Does your name have a surname which comes from a royal family? And there are list of keywords. So you find yes or no. You convert this into a yes or no, whether the royal family keyword is there. Maybe they were given preference, yes or no. That could be one of the variables, but not directly. And again, not worth investigating. So I wouldn't care about name. So I wouldn't care about the data type. I would save time. Just ignore name. Coming to the next one. Gender. What do you think? Should be very, very logical. And this could be preferential. This could be by the rules of the rescue. And by the way, this is real data. These were actual passengers on board, and this is considered one of the most legendary data set because you didn't know anything about the disaster, but as and when you investigate, you start getting to know a lot of things. So let's go to charts again, and instead of P class, so delete P class, put gender in rows. You can use the delete button, or you can make a new chart if you want to. Do you see any interesting things? Yes. Definitely. Out of 314 males, no, out of 314 females, 233 survived. And out of 577 males, only 109 survive. So in fact, we don't need too much of a modeling here. If you're a male, then your chances of survival already have gone down. And you can imagine what would the coefficient of that gender would look like. And we'll see once we run the model, we'll see whether it is positive, negative, how do we read that, whether you're a male, whether the chances of survival will go higher or lower, all that will come in the result. But as of now, I definitely have a case to take gender as one of the important variables. And what I'm going to do now is not spend too much of time, but in a realistic hackathon or your coursework too, you'll keep on going. You'll say, should I consider age? Should I consider this? So right now, without getting into too much pivot tables, just in general, do you think age would be a factor? Worth considering? Yes, definitely worth considering. What about SIP, SP, and PASH? We may not be. Again, we are doubtful. We would do pivots to understand it better. We would see the distribution and all that. But as of now, for the skill set, no harm in taking them and trying. And then let's see what the AI tells you, whether it was important or not. What about ticket ID? No, it's a string. Logically also and technically also, it's not possible. Fair. Do you think we should? Let's see the column. Fair. Now, this is a very interesting variable. Yes or no?
Yes.
Logically, yes. But I would say technically also yes. It's a numeric value. You can take. But there's one problem. To the class, and that's where you start your analyst mindset, and you would say if there are two columns that are essentially representing the same kind of data, and there is a big problem, by the way, when you take both of them together. When you take both of them together, you don't know how the correlation will affect the other variables. So your entire modeling can go here and there. When you know already that there are two variables which are almost representing same thing, it's a crime to take both of them. So either you say, okay, let's drop class and take fair. If you believe fair is a better version of this, but then there is a problem. Like let's say someone could be traveling in class 1 and could not have given a high fare, maybe some discount or whatever. So when you know the class, why should you take fair? I would not gamble with it because they are highly correlated, already represented. So that's taken care of. What else? So cabin 100% no. First of all, missing values are majority. Secondly, it's a text variable. I cannot take it. Also, the cabin structure would be partially represented in class, so I do not want to take. What about embarked? No, I mean, where they embark from does not matter. But what we can do is we can take it in the model to see how it rejects embark, right? We know embark will not be, but just to see our logic, does the AI model actually do it? We can take it as one of the independent variables and see what value does it give to embark as one of the independent variables. That's the process. And imagine in this process, I haven't created any additional columns. I haven't added any additional data from the existing columns. I understood what can be helpful, what cannot be helpful. That should be sufficient for hackathon. For your coursework too, you would think of more. Even for hackathon, let's say age as a column. Now, one thing that you can think of, which we will experiment in Titanic data, is instead of taking age as a actual number, can I create categories of age?
Yes.
Can I say less than 10 as group 1, 10 to 30 as group 2, senior citizens as group 4? So I can use an if condition. You remember the formula, the transformation, right? And I can create 4 groups and take that newer column instead of age as one of the independent variables. That's how you make it better. That's how you make it more representative. And this is all analyst freedom, right? And that's what I'm saying. The tool is there. The model is there. The algorithm is there. Everything before and everything after is your choice. Data IQ will never say, don't do this, don't take that, don't take this. Yes, for text, it will say, I cannot take it. But otherwise, it will say, take everything and do. That's not how you should do. That's where the analyst mind is coming in, making a proper structure and then getting towards preparing the data. So far, so good. Shall we treat our data now? Cleaning part. How do we clean? Which recipe? What? Which recipe for treating missing values, formulas? Prepare recipe. Let's go back to flow. And make sure your flow looks like this. Click on the flow. The options should open up. And let's click on prepare recipe. Time to clean my data. You can name it Titanic prepared or whatever. Create recipe and get inside this. And now I'll tell you step by step what you need to do. I'll not tell you how to do. Okay, now step one, let me address missing values. Okay. Now tell me this. Should I be treating cabin? Because that's the majority missing values. Why? We are not considering it at all. Cabin is not one of our variables, so it does not matter if I clean it, don't clean it. It's not getting into my AI model. I would just leave it as it is. No problem in doing that. Don't treat everything and waste time. If you're not considering it in the AI model, then no need to worry about that. Embarked, we are going to, and I need your views on this. Although we know embark will not be a good variable in predicting survival, but just for the sake of modeling, we are experimenting. Now, here is your chance. I need you to tell me what sort of cleaning can logically apply to embark as a column. So tell me how many are missing. Can you do analyze and check? Oh, by the way, I completely forgot. Are we facing a sample problem here? No. How many passengers were there? 891. So no sample versus thing. So we have full data. So let's go to Embark, click analyze and see how many empty rows are there. 2. Now you have multiple options. Number 1 is either consider the blank values as something. For example, you can label it as missing or port not available, whatever. Second option, you would say 2 rows out of 891 does not make too much of a difference. I can delete the 2 rows. Okay. However, that would be a bad strategy if you have 25 rows missing. If you have 25, you will not delete 25 passengers. But with 2 rows, you can take the risk. That is a possible option. Or you can just put actually missing value, or you can say missing is the value for embark. Which one do you want to try now? Shall we try missing? All right, let's do that. So what I can do now, you can do. So wherever it is missing, the value should be missing. Try how we can do that. That which method did you apply? Rename. Okay. Others. So you can do it right here in the analysis stage, or you can do it with find and replace. You can replace the missing values with a certain value. So best is to do it here. I can say missing. That's it. So I've labeled the blank as missing. This is one of the methods. The other method is when you click here in more actions, find and replace. That is another option that you can do. Best is to rename. Rename your 2 values as missing values. So you didn't delete the passengers, but if you delete also, it's not a major crime. It's only 2 rows out of 891. So not an issue. You can give any label. You can call it missing, no value, whatever. Does not matter. Anyone who couldn't do, please let me know. I'll come and do a part. All good? Shall we move on? Now the tougher one. Let's move on to age. Now that's a bit tricky. Now everyone be very careful here. First of all, I will check how many are missing. 177 rows are missing. So tell me this. Is there an option to delete 177? No, definitely not. That's a bad idea. Option number 2. Can I put missing as a label?
No.
Why? It's a text format, correct? And this is a number. You are actually taking it as a numeric value in the AI modeling. And when you take it as a numeric value, 177 of them are text values. You're messing it up. What are the other options?
The computing
Yes.
the
Sorry, converting into age group that we can do. We'll try that later, definitely. So that's second method where you can do age groups and then you can create one group as missing values. But the problem is if 177 of them make one group, the AI model will consider this as a proper group. And then all the relative coefficients and everything might get impacted. So you don't know what these groups are. Definitely one of the strategies, but I'd be a bit careful in renaming this group as missing group. So that's possible, but I'll be careful. What else? That's a good idea. Take average of the age and fill the missing value with the averages so that the overall distribution is not changed. And when you do the modeling, the numbers are not impacted much. Filling with average is one of the methods. Another line of thought, some people say, no, don't take average here. And there's a good reason for that. They would say when you look at the distribution, you have all the age groups, right? So you have people who are from the lowest all the way till the highest. When you take average, for sure it will be somewhere in the middle. That means you are sort of assuming, yes, you're not disturbing the distribution, but then most likely the average would be a middle age group, right? So there are other ways. What is that other way? Other than average, what else can you fill with? Median, mode, etc., which looks at a more finer distribution. So mode says whichever is the frequently occurring value that you should try more. Median looks at, how it deviates and so on. Various methods, there is no right or wrong here, right? The only thing you need to make sure is it's not disturbing the overall distribution. And do I have a logic in filling that? Again, GPT Claude is also a great tool that you can use in your coursework and your hackathon also. You can copy and paste all the values and you can say so many are missing values. Which mathematical parameter would be the best to represent the entire data without disturbing the distribution? So a lot of possibilities. Again, nothing is right, nothing is wrong. The only thing which is wrong is deleting. 177 you cannot delete. It will change majorly all the impact. So let's look at what the options are and where the options are. So if you click on age and if you click on more actions, you see it already has a pre-build. Fill empty rows with and you get more options. One school of thought says, if the passengers are sorted in a particular ID, then whichever is missing, just take the previous age of that. But that can only happen if it is nicely sorted in a certain way. I wouldn't take that risk. So I will click on fill empty values with. And this is your choice. You can either put a number and say 25, I would put, or mode, which is the most frequent value, or average, or median. The choice is yours. Let's do all the same thing. Which one do you want to do? Mode. Let's do mode. I'm also aligning more towards mode and click OK. If you made a mistake, you can delete that step, repeat the new step. All steps are sorted here. Correct. Which passages are where? That's the kind of analysis. 100%. So if let's say if this was your coursework too, or even if you have time to hackathon, that kind of analysis will be beautiful. And this is what you want to see. As an analyst, have you arrived at the right decision? And I would do that. I would take the missing values, compare it to the non-missing values, see the distribution of survival, not survival, survival, not survival in the missing versus not missing, and then take a decision on what it. Great idea. As of now, we are just keeping it minimum so that we can see how to run the model. But in a realistic project, that would be phenomenal. Good idea. Anything else that is remaining? All right, let's do one more step. We will not use it in the first model. In the first model that we run, we will use age as a number, but in the second model, we'll try it with the categories. But what I want you to do now, and let's see if you are comfortable with the formulas. I want you to create three age groups. Group one, group two, group three. Anyone less than 10 goes in group one. Anyone from 10 to 60 goes in group two, and anyone greater than 60 goes in group three. Let's create three groups. Let's see if you can try that. I want you to create a new column. Don't replace age. Age should remain over there. You have to create a new column called age category, in which group one represents 10 and below, greater than 10, less than equal to 60 is group 2, and 60 and above is group 3. Try with formulas. Let's see. And again, you can take help of GPT, you can try formula yourself. The only problem is there are multiple if else here. You can try the if else also. That's also a possibility. The new column is called age category. Group 1 less than equal to 10. Group 2 11 to 60, 61 and above group 3. Less than, I can write it down 1 minute. There you go. Less than or equal to 10, group 1. 11 to 60 should be group 2. Greater than equal to 61 should be group 3. Yeah, just 1 minute. Okay, sorry for that. There you go. Less than equal to 10 G1. Anyone who successfully done? Nice. Using if then or formula. If then. If yeah, if then. Yeah. If. Nice. Good job. I think if then else will make it more structured for you, but if you want, you can ask GPT to create a if else formula also and then give you directly whatever works. If you type it yourself, it might be a bit complicated. You need to be very clear on what comes in if, what comes in else, and so on. Remember, it should be a new column. Don't replace age. Otherwise, you won't be able to do the modeling with age. The new column should be called age category, and it should not impact your existing column age. And what I'll do is, since it's not needed in modeling one, I will not give you the answer right now. If you're not able to do, that's fine. You can just delete that step, but you can try it later. And next class, we will do it together when we actually run it. If you're able to do, good job. Done with if then else. Anyone trying with the actual formula? If writing if, or everyone is trying the if then else itself. Okay. If you have completed or not, depending on if you have got the answer, then you just click run and keep it ready, the transformation. If you're not confident, it's okay, just delete that step where you were experimenting with the new column. Just leave it, it's not required as of now, and click run. And make sure that your flow looks correct. Don't stress too much. You can try later, that, give them else. Done? Done? Or you're doing it later. If you're not able to, yeah, that's okay, just leave it, just click on run. Go to the greater than equal to yeah, so you can delete. If you're not able to do, you should also know how to delete. Just delete the step, the third step, and then click run. So that whatever you have done, the changes apply. And let's get back to flow. Yeah, run all the changes, yeah, and come back to the flow. So we are still in data preparation. This is not the model stage, so you don't say run the model, run the changes. Yeah, all good. It is good. Yeah. Greater than greater than equal to 61. Greater than equal to 61. So anything 61 and above should go into. Those who did, put your name forward. Utkarsh, yeah, can you tell me, are there any people in group 3? If you analyze that column, the G bar, it will show you how many. There are. Yeah. No, say it should be, you are assigning age category and group. I'll check that later. As of now, you can just delete. Yeah. Yeah. Correct. Oh, that. Oh, nice. Okay, perfect. That's how we run it. You can run and how to just go. Guys, don't stress about it. We'll be revisiting this later. If you find it confusing, just delete. Only thing you will be missing is that column. Okay, now we are moving to a very important step, and I need your attention, and that's why I'm saying if you have not done it, it's okay. Just delete, run, make sure you come back to the flow, make sure you see two blues, not the half-baked one. If you see two blues, that means the prepared recipe has run successfully. You should have the original data, you should have the prepared data. And for next step, I really need everyone to focus. It's a completely new concept. So please pay attention. Anyone who needs help in either deleting the step, coming back to the flow, please raise hands. There, all good? Yeah, okay. Go back to the flow and check if this is how your flow looks like. You should have your data, you should have prepared recipe, and you should have the prepared data with you. Okay. All good? Yes. Yeah. All right. Now, everyone, pay attention. This is very, very important. We are still not ready to run the AI model, and there is one very, very important step. Conceptually, you need to understand that step. But before that, let me show you. When you click on Titanic box, now you get some options. These are related to Titanic dataset. When you click on Titanic prepared, you get there, both of you will get confused. Please have a look here, then I can help you. When you click on Titanic prepared, you again get a set of options, but these options will apply to Titanic prepared. So be careful in the next recipe that you do, you should have a clear understanding. Are you applying the recipe on the original data or are you applying it on the prepared data? And both these options are different. You can further make a prepared recipe on this and then do another preparation. That's completely up to you. But when you click this, these options are for prepared. When you click on Titanic, those options are now for Titanic. These are two separate data sets in your existing project right now. Now, the concept that we are about to introduce. Ideally, we are good in running the logistic regression model. Data has been prepared, we have understood the columns, we have understood domain knowledge, missing values have been treated. Ideally, it looks all good. And at this point of time, I can run logistic regression. But there is a small problem. The problem is when I run logistic regression, it will give me the results. Everything is good. But how will I know how good that model was? Can anyone? But then how would I know? Right? So let's say the model ran and it gave me the results. And okay, in fact, let me ask you another question and check if you can answer this. How many passengers were there in this data set? 891, right? Now imagine I ran the model, I did logistic regression, the model is ready. Now what I do is I check back the results for the same 891 passengers, which means what I'm doing is I will hide whether they survived or not. I will only use the other variables, ask the model to do the prediction and compare it with the actual answers. And I can see how many of them are matching, how many of them are not matching. Do you think it's a good strategy to figure out how good that model was? I repeat, please listen very, very carefully. I have the model, I have the algorithm, which can take anything and it will give me a prediction. And I come up with a strategy that why don't test it on the same 891 passengers and see for how many passengers the algorithm says survived or not survived and match it with the actual survived or not survived. Good strategy to understand how good the model was. Everyone agrees? Big problem. And that's what you need to understand about AI. The biggest problem with AI is if you test it back on 891 passengers, the accuracy will be 100%. That's what AI is supposed to do. It is supposed to read your data. It is supposed to make model based on that data so that whatever model it has done, it is first applicable on the same data. So essentially what you're doing, you trained the machine. Now we are talking machine learning. You trained the machine with 891 passengers and you tested it back on the same 891 passengers. Accuracy will always be 100%. Because it got trained on that model and on the same data, if you test it again, for sure, you will always get 100% accurate model. And that is not a benchmark on how good the model was because model will always be 100% accurate. Right? Now you're stuck and you're saying if everything will be 100%, it will test. What do you think can be another strategy?
There's something similar to our.
Yes, that's a good, very good way of thinking. In fact, for logistic regression, it's not a direct R square. There is a parameter called Mac-Run R square, which sort of mimics the R square and tells you how robust the model is. You remember what was R square? R square was never about the accuracy. It tells you how confident you are about the model, which we can have some mathematical parameters. Great guess. Which can show you how confident you are about the model, but I'm talking about testing. I'm talking about accuracy, testing in real time, whether this is something good or bad. So we'll come to that. There are some mathematical parameters, agreed, but that gives you confidence about using that model. But we are talking accuracy. Is there another strategy now? I think you can answer. Very, very easy question.
Fill out the details.
How do you fill out the data?
These take different values from different tests that whether things.
Correct. That's a great strategy if I have more passengers with me. So imagine I have additional 20 passengers and I know whether they survived or not. That is a great idea. Then those additional 20 passengers I can put in the model and ask model to predict whether they will survive or not. I can check with the actual answers whether they survived or not and get a guess on how good the model was. Great. But now I'm stuck because I don't have additional 20 passengers. Correct. Great strategy. This is what is known as splitting your data into training and testing. Now, I'll be careful with 500. So she said, you have 891 passengers, so why not train for 500, reserve the remaining 300 something for testing, and then you can test. But I wouldn't use that number, 500 and 391. Why? I would be a bit careful in that kind of splitting. I would split it, but not with 500 for algorithm and 391 for testing. Why?
For testing,
Number one, so that's a great answer. So Utkarsh says for testing, you don't need that many number. I would actually put the opposite. For training, you actually need big number. So imagine out of 891, if you are only giving 500, that means the machine is only learning from 500. And the equation will only be representative of 500 passengers. And it's a big number that you haven't provided the machine to learn from. So the thumb rule is always give majority of your data for training so that it learns the maximum patterns. Keep minority of data for testing. Usually they say 80-20. At least 80% of your data should go for machine learning. 20% of the data you can reserve for testing. So, and that's a great way of finding how good the model is because that 20% was never used for model building. That's purely for testing, which means I can ask the algorithm, look into that 20%, give your predictions. I will compare it with the actual answer and see how many of those passengers match, how many of those passengers did not match, and that gives me a better sense of accuracy. Again, 80-20 is a thumb rule. You need not strictly follow 80-20. So, for example, how many passengers are there in the data set? 891. I can roughly say 800 for training and reserve 91 for testing. And this is called the training and testing strategy. Once you have the train data, once you have the test data, on which data will you apply logistic regression? Train data. That's where the majority is. Those 800 passengers, you will take train data, apply AI, you will take test data and test the model. And that's when you will come to know how good a model you have built. Ready to do the split? We'll do only till that part. We'll split it into test and train. We'll go to train, see the train data. We'll go to test, see the test data, and then get ready for applying logistic regression in the next session. Okay? One more question. How do we split? No, I mean, not technically. The method. There are various ways of splitting. How do I get 800 out of 891? What are the different ways? Perfect. So, Uttar says you can take it in order. First 800 passengers goes into train, remaining 91 goes into test, method one. Not the usually considered method because your data might be sorted in some way. And if it is sorted, it could introduce some bias. Maybe all the non-survived were coming first and you took, majority of that. So you're not giving enough representation. So one way is sequential. Another way is random. You would say randomly take 80% so that I'm not creating any bias. The remaining 20% would go in test. That is method number two. Method number three, what analysts usually prefer. They want to keep the same distribution. Gender becomes a bigger factor, right? Age becomes a bigger factor. So they would want to split the data in such a way that the train distribution of gender, age, etc. almost resembles your full data. Why I'm saying that? Companies have made mistakes. I don't know if you heard about the IBM story, where they use bots to screen the seats automatically. So automatic first level of shortlisting was done by bots, was done by AI. The problem is when they made the train data, majority of the CVs were males, and the machine learned only those attributes. And when it actually came into production, it was only shortlisting males because your training data had that bias. So ideally, you should make sure that training data is fully representative of the entire population, and then you apply the model. We can try different methods. We can try one algorithm will try sequential, one will try random, one will try stratified. We can try different methods so that you get the entire flavor. Shall we do this? Yeah. Okay. So now click on prepared, not on the original one. You're not splitting the original one. You're going to split prepared data into train and test. And now you can tell me which recipe should I go for? Check the recipes on the right side. Which one do you think? Split. Yes, you see, it even shows. So let's click on split. And you should land up on this page. All good, everyone with me? Now have a look. Please focus here. It says check if it says Titanic prepared. That's your source data. It says that's your input. What do you want your output splits to look like? So what I will do is click on add. I will say one data set should be called Titanic train. I'll create it. And another data set should be called Titanic test. And I'll create it. So you can see visually, this is the original data set. It should be split into two, train as well as test. Train will have majority of my data, test will have minority, and then I would use train for AI modeling later. Remember, right now we didn't specify the method of splitting. Right now I've just given names. Train and test are the two output, and click on create recipe. Yeah. Sorry, yeah. That's because you didn't run. Okay. So just click prepare and it's not completed, right? Yeah. Yeah. Now test. Not for this, yeah, I clicked on, you can see, so it's taking prepare, and then you are getting. Anyone else? Okay, now, as you can see, everyone, last part, as you can see, there are various ways of splitting. You have random data, in filters, you can have those distribution, you can say what percentage of gender, what percentage of age, you can try that. Dispatch percentile, so you can say 80 percentile here, 20 percentile there, or you can do sequential. So for example, you can take the ID column and say first 800 will go in train and remaining so on. Let's try random. So let's click on randomly dispatch data and see how visual this is. I mean, the tool is just mind blowing. So it says I'll do a full random. Again, you can have different types of random, and it says what ratio do you want of the randomness? What ratio do we want? 80-20. So ideally, you can just make it here, or you can put the number 80 here. Oops. Okay, so just make sure which one is going to which part. Check the majority is 80 percentage, it's going in train. Minority is 20, it's going in test, and everything looks sorted. Visually, you can see which is majority, which is minority. If your train and test is interchange, you can change that. Just make sure majority goes in train, minority goes in test, and that's it. You have split your data, and when you click on run, it will take your data, it will split it into two parts.
So, why are we going for 80? We can go for 90.
You can go for 90, then also 10 percentage also leaves significant, and that's your choice. As far as you're giving 80% minimum, then it should be significant. The result should be good. But up to you. You can make it 90-10. I wouldn't recommend 95-5 because then there's less for testing. 90-10 is okay. 85-15 is also okay.
So,
Yeah.
it will only, 80%.
Yeah, so it would, and that's what we are reserving for. So we are saying majority of the data, it is already learning. That should be good enough. If it was only 50 that it is learning, then there is a problem that I leave out half of the data. I can tell you, guys, good question. So what he was asking is everyone, there is a random seed number that you saw. What is that seed number? So basically what it allows you to do is track back on the randomness. So let's say you run again random and then you say, okay, what was the first random that I ran? With that seed, you can reach back to that, but we don't use it. So don't worry about the seed number. 100%. Everyone, good question. Does the ratio depend on you? 100%. Up to you. I would say minimum is 80 percentage, and I would say maximum is 93, I mean, not even 95. Maximum is 90, I would say. If you make more than 90, then you are reserving too little for the test data. If you're making less than 80, then you have too little for the train data. So 80 to 90 is your playground. You can take a call. You can make 85, 15, 90, 10. But yeah, nothing less than 90. I mean, nothing less than 80, nothing more than 90. 80 to 90, you can definitely. Yes?
So, taking long distance, how do you want to notification or in our data for the
In fact, once we run the model, it exports everything in Python. So whatever you are doing at the backend is generating a Python code. So you can take out the whole code and you can use it with the app. Done. Which I'll show you once we run. All right, last, everyone, just check. Now just check. Please come back. Please come back. Then we finish the session. First of all, excuse me. Come back flow. Just click on flow. Every time come back on flow. You need a bit more practice. Once you come back on the flow, make sure that these are blue boxes. Train is separate, test is separate. Can you tell me how many rows were there in train? Click, go inside train, check how many rows are there. Let's check. 713, that's right. And how many rows in your test data? 178. Yep, that's how 80-20 should figure out. And again, make sure that none of these are dotted. It's complete blue, which means your data is prepared. And now here is the best part that we'll see next time, everyone. Now, the moment you change something here, everyone, please pay attention. You need to understand data IQ because all the algorithms will be affected that way. So if you decided, oh, I forgot to do one step in the prepare recipe, you can actually double click on prepare recipe, make the change, and then ask data IQ to apply the change in the entire flow. So you have an option. Either you can make the changes only for this, or you can push it all downstream. And that's the power of data IQ. At any point of time, you can go back and forth anywhere. The entire changes will be reflected. So next session, what we will do, we will click on train, and then we will click on a recipe that can do logistic regression for us. We haven't even started logistic regression. So once we click on train, we find the recipe which will do logistic regression for us, and then we run the model and we see the results. Any questions? All good? If yes, then I'll see you all tomorrow afternoon. Thank you. It was recorded, yeah.
So just a quick question. How
Go
long
ahead,
does the
please.
recording take to show up in the system?
I think 10-15 minutes.
Okay, thank you.